Hi, my name is Joshua Jones, and I'm a technical artist here with Magic Leap as part of our Learning Resources team. In our next series of videos, we're going to dive into how to visualize PCFs inside of Unreal Engine. PCFs, or Persistent Coordinate Frames, are 3D points in space that are created on the Magic Leap headset that allow you to be able to anchor content to the real world and have it persist across multiple user sessions. In our series of videos, we'll go over how we can actually access the AR pin information inside of Unreal Engine, how it relates to PCFs, and how we can actually visualize that information utilizing 3D Axis, text renders, and more. In order to get started with visualizing PCFs, we'll need to go ahead and have a project that's been configured for Magic Leap development. The Magic Leap template is a great way to go ahead and get started with this tutorial. Or, if you want to use an existing project, just make sure that you have your BP pawn created and that your project has been properly configured under the Magic Leap settings. We'll go ahead and configure this one now, since this is a brand new build. Another thing to keep in mind here as well is under our project settings, since we will be using PCFs, is back under the Magic Leap panel. We'll scroll on down and go to our app privileges, and we'll make sure that our PCF read is enabled. If you're using the Epic Game Store build, or if you're on SDK 22 or higher, this will automatically be a part of your manifest. First off, we'll create an actor that will be a representation of the axis that we use inside of Unreal Engine. This way we can actually see the position and the orientation of a PCF in 3D space. Let's go ahead in our Blueprints folder, or anywhere in the content browser. We'll go ahead and right click and select Blueprint class, and we'll create a new actor. This will be called Axis. We'll go ahead and double click and open it up. And let's go ahead and add a component, and we want a cylinder. We'll name the cylinder up to match our z-axis. We'll move it up 25 in the z direction, and we'll scale it down to 0.03, 0.03, and 0.5, and let's change it to be blue, and I'm sharing blue. If you do not see this, make sure that under View Options that Show Plugin Content is enabled. We'll go ahead and duplicate our up, and this will be our forward to match our x-axis. We'll change our z value to 0. And actually change this to 25. We'll change our rotation to 90. And we'll change our color to red. Let's duplicate our forward one and name this one right to match our y-axis. Location will be 0, with the y being at 25. Our rotation will be 90, and we'll zero this one out just for cleanliness. We'll change this one to green. As you can see here, we now have a 3D model that correlates to the same axis that we see down here in the window. We'll go ahead and make sure that Save on Compile is always enabled, just for sanity's sake. So you can hit Compile and Save, or just Compile. We'll go ahead and close out the axis for now, and we'll create a new Blueprint class. We'll choose Actor again, and this will be AR Pin Info. This will be the actor that we will spawn for every PCF that we do find in a scene, and store information from the PCF into this actor so that a developer can see a lot of the information that is being brought up. Let's go ahead and double click and open up on AR Pin Info. Let's click on Add Component, and we'll type in child. We'll name this child our axis, And over the details panel, we will click on child actor class and select access. We'll scale this down a bit. We'll actually scale it in half and put it 0.5 across the board. We will then add a sphere collision to use as a debug, and we will name this valid radius visualizer. And in the details panel, where it says hidden in game, we will go ahead and uncheck, so that way we can see this at runtime. On add component, we'll add a text render, and we'll name this one pin ID. Make sure that it is not a parent of valid radius visualizer and actually only a parent of the default scene group. We'll change the size to 6. We'll set it to be center and text top. We'll put in some temp text here just so it's easier when working inside the editor. And then we will change its location to be -3. Click and duplicate pin ID, and we will now get the confidence label. This will be set to -9, and text will be aligned to the right. And we'll name this confidence : we'll duplicate this, and we'll get our rotation error label. Set this to a value of about -15, and we'll say rot error, and we'll duplicate again and do location error label. Lock error, and then we will move this down by -21. So these will be our labels, and then we'll assign an additional text renders here that will actually be the information that we get from the PCF. We'll go and duplicate our confidence label and type in confidence value. We'll change our horizontal alignment to left, and we'll put in 0 for now. We'll duplicate that again, move this down to -15 to line up with the rotation error. And we'll name this rotation error value, and duplicate one last time for location. And set this to -21. We'll go ahead and just compile. This way we can save. So we have every one of our components that we'll need. So that way when a PCF is found, we will spawn this actor, and we'll grab the confidence, we'll grab the pin ID, we'll grab a rotation error and the location error as an estimate of how close we are to actually the PCF. We will see the validation radius to see how big that radius is actually going to be in that area for the PCF. With that done, let's go ahead and click on the event graph. And let's go ahead and get rid of our event begin play and event actor begin overlap, since they will not be needed. We'll go ahead and create a new variable called pin ID, and we'll change it to a GUID value. And we'll go ahead and make it instance editable. We'll go ahead and compile it. Instance editable just means that if this is enabled here or not. we'll go ahead and get this out for now. And from our event tick, we will click and drag to an empty space and search for get AR pin position and orientation. We'll then connect our pin ID. And so we'll grab the ID of the PCF, and then we will grab its position and orientation. So this way we can actually move our actor here to these values. But first we need to make sure that this object was actually found. So we'll go and do a branch. And then in order to toggle our actor if it's valuable or not, we'll go ahead and do from or true to set actor hidden in game. And then we will duplicate. So if we're not found, we'll hide it. What we then want to do, so if it is true, we're going to set actor location and rotation. And these will be based off of our get AR position and orientation. So we'll go ahead and wire in these. We'll keep it as a reference to ourselves, since we want our overall AR pin to move. Now let's go ahead and start filling in our values over here. Let's grab in our components panel the pin ID and click and drag out. And from pin ID, we will look for set text. We'll go ahead and wire this in. And then let's grab our GUID. We'll do a get, and we'll say from here to string, and then from our string value to here. So we need to convert the value of our GUID to a string, then the string to a text, which will be done automatically, and then this will be fed into our text renderer. So now we'll go ahead and just reuse our AR pin variable here. Get AR pin state. And this will give us some information about the AR pin itself. So what we want to do is from the state is find a break magic leap AR pin state. So this will grab the PCF information, our confidence value, our valid radius, our rotation error, and our translation error, or as we've called it over here, our location error. But first, we want to make sure we only grab the PCFs that we care about for this example. So in this case here, we'll do an equals. And we want equal enumerator. In the enumerator, you can see here that there's none, low map quality, unable to localize, privilege denies, unavailable, unspecified failure, privilege request pending, and invalid parameter. These are great ways to be able to check to see if something is not working as intended. But if everything's going through as it's supposed to be, none will be returned, which is what we want. We'll go ahead and create another branch node. And if it's true, let's go ahead and start wiring all these up. So let's grab our confidence value. And from our confidence value, we'll do a set text. And we'll feed this into our value. We'll go ahead and get our rotation error value. We'll create a duplicate of our set text. Connect. And same thing over here. And again, rotation. Whoops. And location. We'll duplicate our set text. And translation. Now for the sphere radius, what we'll end up doing is we're going to go ahead and grab our valid radius visualizer and type in radius. Here we'll see where it says set sphere radius. Turn off update overlaps since we're not using it for collision purposes. And grab our valid radius and feed it into here. So, our AR pin info is now complete. So now for every tick inside the scene, we'll grab our pin ID, which will be given to us by the PCFs. We'll grab the position and orientation of this single PCF. We'll verify that if it's still an active PCF to be used. If it is, we'll go ahead and unhide this actor. If it's not, we'll go ahead and hide the actor. We'll set the location and rotation of the AR pin info based upon the information given to us by the AR pin. We'll go ahead and take the pin ID and we'll go ahead and set the text so that way we can see it. We'll get the same AR pin state and break it apart, verify that it's not pending on any potential errors, and then start feeding in information for its confidence value, its a rotation error, its location error, and then change the radius of the sphere to show any validation radius errors. We'll go ahead and click compile, and we'll go back to our scene.